Hi friends, today welcome to my channel. Today we will discuss about the time period of a satellite. Means we will derive the expression for time period of a satellite. In the previous lecture, we seen how satellite means what are the forces acting on the satellite and what are the laws. And finally, we described means we derived the equation for the Kepler's third law. Like that, here we'll see the time period of the satellite. Here normally we call time period. What is time period? If your earth is there, then here we consider around one orbit, whichever the orbit means lower earth orbit or is a upper level orbit, anything level orbit. Here one satellite is there, consider it as a satellite. Then it takes time, means what the time required to complete from here to again to complete one revolution around the earth and again come to the same point, that is called time period of one revolution. Means this one is, we call it as a one revolution. So to complete one revolution of the satellite around the earth, how much time is required? That time is, we call it as a time period of the satellite. Here that is the concept. Today we will derive the formula for the time period of a satellite. For as we know, this one also we derive from the normal as the previous class. In previous class, what we discussed, here for every satellite, in normally satellite there are two forces will apply. Those are centripetal force and centrifugal force. We know F out and F in. These are the two forces. Here we will write centripetal and centripetal forces. F out is equal to F in. This one we seen in previous class also. Okay. What is the formulas of F out and F in normally? If anything is happen, normally G for mm by r square equal to mv square by r. This is the formula. We all know this formula because in the previous session we discussed about this formula, how this formula is came and what are the parameters of this formula. Here m is the mass of the earth and v is the velocity of the satellite, sorry, mass of the satellite and velocity of the satellite. R is the radius between, means not radius, distance between the satellite and the earth here. Okay, from this we can say we normally know it is in angular motion, no? So we can derive the value for acceleration. Means what is the value? Velocity by radius. Then for what we can say, here in if velocity we consider in means angular, then omega r. Okay, this is the formula for velocity. Then if you consider v equal to omega r square. Okay, sorry, v equal to omega r, we can call it as omega. Okay, v is omega in velocity. Okay, uh, omega, then we can write it as a v equal to omega r. So I am replacing this v equal to omega r in here, velocity of the satellite. So g m by r square, m omega r whole square by r. Okay, this is the formula. Now what we need, we are getting means what we need to do means omega square we need to separate here from here. So I am doing, before that I am cancelling the values. What are the same values? R, here r is also cancelling. Then omega square equal to g m by r cube. Okay, this is the formula we get. Now what is the time period? If you consider time period of a pendulum or a time period, then what is the formula for time period? We all know 2 pi by omega. Okay, then here we have omega, so angular velocity, so we are replacing omega to this side and we are changing 2 pi by t time period. So we will replace this omega value in here. Then what we will get? 2 pi by t whole square equal to gm by r cube. Okay, from here we all know Kepler's constant is what is the Kepler constant? Mu value is some 6.40, some into 10 power 5, some value is there now, so it is equal to gm. So we can replace with gm with mu by r cube. Okay, here 4 pi square by t square we will get. Okay, then I am changing t square, I am getting equating the value t square. We need time period now, so 4 pi square r cube by mu. Here we get time square value, so we need only time period which is t, so we will get 2 pi by square root of mu into r power r 3 by 2 means cube root of the square r square. So here we can use r as a r, here or otherwise we can replace with the semi major axis. The distance between the earth and the satellite we can take it as a semi major distance. So in that time semi major axis value is, if you consider it as a, then we can replace it with a. So value time period value is, time period formula is 2 pi by square root of mu into a power 3 by 2. This is the time period for the satellite to revolve around the earth, uh, time period taken for one revolution. This is about this class. Next class we will come with another topic. After now, thanks for watching the video and please subscribe to my channel.